Hi there, welcome to my No BS gear review channel. Tonight we're looking at this knife, Machine Rosie. So tonight I'm going to start actually with a box, because the box says proudly made in the USA. So to me, when there's something like that on the box or on the knife, it's not a geographical statement. To me, it's a promise of highest possible quality, no corners cut, no compromises taken. And so tonight, I'm going to find out if this knife measures up to this statement. Most of the reviews, quote unquote, that you find on YouTube talk about how great the deployment is on this knife. And so I'm going to start there. It is not equipped with a front flipper or a regular flipper. It just has the thumb hole or finger hole, and it deploys two ways, right? With a thumb flick and with a reverse flick. Please notice that if I had to do any of this, like that, with a wrist, to deploy it, I would not score a point, but I do it from just like regular hold position, and that's why it gets full point for this. And I saw at least one review where they said it was difficult to use the thumb. You have to understand, when this guy designed the knife, he thought of every freaking detail. So this here is not just for looks. When you put your thumb this way and follow this line, it will force you to open the knife. All you have to do, put it in, slide it open. That's it. That's what this is here for, not for smiley face. But on top of that, I discovered a new way to deploy it, and I'm going to call it a lefty flick. Here's why. Imagine you are left-handed. This knife does not have a reversible clip. And so it rides in your pocket like this, blade forward. When you pull it out of the pocket, for you to flick it the normal way, you would have to rotate it and open like that with a normal knife, not with this one. You can pull it out of the pocket and flick it like this, and then it lands in your hand, thusly, in a perfect defensive position. So, let me do it again. Here you go. Easy peasy, and this is my weak hand. I can do it with my strong hand all day long, not even flinch. So 3 points for 3 ways to deploy it: thumb flick, reverse flick, and a lefty flick. So the Rosie is classified as a small to mid-size, I'm going to say mid-size pocket knife. And one of the keywords here is pocket. So this pocket clip has been talked about enough. I am eager to find out how it works in my pocket. And for that purpose, I'm wearing the pants that have both a jean thickness pocket insertion point and a thinned out knife clip insertion point. So I'm going to test it on both. As you can see, it pushed itself out of the way due to the ramp, and it extracts easily without excessive force. I have to be a little bit more persuasive with it than, say, with a Spyderco wire clip, but not by much. We'll quantify all this in a minute. And so here is the thinner material, and obviously it got in without the problem. But let's measure it anyway, and for that we're going to use my EDC meter. So here is the webbing belt that imitates the jean pocket. It's 1/8 of an inch thick. And some knives that have overly tight clips, I can't even push them on because the edge is rather rigid. And please, I understand this is not exactly how it feels going in the pocket, but this is a test. It has to be repeatable from knife to knife, and that's why I chose this method. Sorry, I'm taking a little more explanation time in this video, but something tells me everyone will watch the whole thing. Why do I spend so much time talking about pocket deployment? So many knife reviewers spend hours of your time making you listen on how important the pocket clip is. And no one measured it. 3.24. So it's in your pocket there. Ah, sorry. Redo. 2.65. So perfect. Definitely scores a point. Yeah, so let's check the weight. So it's 84 grams. 2.96 pounds. We call it pounds. 2.96 ounces. So as you could see, the forces were perfect, so it scores the point. And we just record the weight. And here's this acceleration test that I think emulates tumbling down a slope of a mountain or being in a car accident. So it passes. 3 points for the clip. So let's see how it measures. I measure from where the handle ends and the blade begins. That's the legal way to measure blade length in Virginia, where I live. And I'm getting 3 1/16. And in millimeters, it is 78 millimeters. Now I'm going to measure the cutting edge. So I'm going to the end of the finger choil, sharpening choil, whatever is on the knife. And then I just roll it. And it gives me a little more, at 3 1/8 or 80 millimeters of the cutting edge. So already we're in a good place here. Now I am going to take and test its cutting board usefulness. What I mean by that, in case you choose to use it as a chef's knife, cutting vegetables or meats on the board, how much of the useful edge you get. The way I do it, I put my finger in the choil. And this knife has 2 choils, so we're going to check both. And I roll it down until my knuckle hits the board. And here I am getting a 1 9/16 of an inch. You know, about 38 millimeters here. And that gives me more than half the blade's length ratio. But wait a minute, it has a second choil, so if you really were going at it, you can get even more edge out of it. It goes to 2 full inches. So it definitely scores that point. Next stop is almost at factory edge, but there's no factory, it's a shop. So as delivered edge, and that's my favorite because that informs me how professional is the person who sharpened the knife. Look how professionally is the tip sharpened. It keeps picking up some lint. I want you to look at this line, how it swoops in. You don't see it very often. If you watch my videos, you know what I'm talking about. You will not find it on a production knife. All right, so what are we seeing here? See this shiny line along the apex? Let me flip it over. You see it on both sides of the blade. And that is just a tiny micro bevel or maybe evidence of stropping. And it's totally the right amount of stropping, unlike many, many other knives that I've seen that either have too much or not at all. And I would like to point your attention to the consistent width of the secondary bevel here on each side of the blade. That indicates that the grind angle is constant until it gets toward the rear of the blade and it widens and gets into the thicker part as it rides up to the primary bevel. This blade has like an almost hidden design feature. It's called distal taper, meaning it's wider, thicker in the back and narrows toward the front. That gives you very slicey capability in the front and good penetration and much more toughness toward the back. So I think, and I don't know if it was done on purpose or by accident, that's why let's look at the opposite side. And the opposite side continues or maintains the same width throughout. If it was a $200 knife, I would leave it at that. But on a knife as expensive as this, I kind of expected a little better. Because I would have to remove lots of metal to perfect this secondary bevel if I so chose, which I'm not sure I will do. And while we are here, let me show you what the handle, that milling pattern on the handle looks like under the microscope. Danny calls it a radial frag, and it's a dark tumbled finish, which is, I think, is the latest addition to their lineup. The tumble pattern looks very consistent. They clearly did not cheap out on the tumbling abrasive media. It has been said that the hardware for this knife is machined in-house, and I see clear evidence of that. There is a mill and then smaller mill pass to create the Torx pattern here, and on the other side it looks the same. And the spacer screws are machined in-house the same way. Look. Let's look at the apex like this. You have to pardon me the pun. This is not just an apex. This is a pinnacle. Look at it. Not a single imperfection, no striation out of place, absolute symmetricity. I don't know, masterfully done. Hands down the best apex I've ever seen in my reviews. But will it cut? Sorry, that was my homage to Forged in Fire. And what you see here is my trigger gauge, or Newton meter. And it's a 50 Newton gauge. And as I showed in many other videos, I made these loops out of 4-pound fishing line. This is it. I got it at Walmart, very inexpensive. Fishing line is rated for both breaking strength and elongation. So I had a lot of luck getting consistent results from this test. It's not dissimilar to BESS test, but it uses this media instead and a straight pull instead of a leveraged push. But the nature of the cut is the same. You just can't correlate the results. And what we're getting here is sharpness in a 400 gram region, pretty consistent here. I will then average them out. I usually do 3 to 5 measurements, depending on how divergent they are, and then calculate the average. And I don't throw outliers in this test because I simply don't know if the line lands on a striation or on the peak between the striations. Why is antler such a perfect media for testing blades? It has high mineral concentration in its composition, so wear resistance will be tested. It also has a lot of fibrous substructure there, which will test the blade for chipping. And the toughness of the apex will be tested because it's a little bit viscous, so I've seen it roll the edge on several knives that I tested. Check out my EDC meter playlist. I try to keep the pressure consistent. I measured several times. I exert about 2 to 4 pounds of pressure on the blade, and it's been working out quite well for me. Write me a comment if you don't like this test method, or if you think it's okay, write me a comment as well. And now we're testing post-torture. And we got a little bit of an increase, but let's take a few more measurements before we jump to any conclusions. While I'm doing this, I would like to thank all of my subscribers. I also would like to thank everyone who comments. If you don't read comments under my videos, you are missing out. I get some of the smartest, most knowledgeable people in the hobby, in our knife community, commenting on my videos. Even the ones who don't like my tests, there's much to learn from their comments as well. What I do ask you, if you come across some kind of trolling going on, please don't respond to them. I don't care what they think about me. I am here for you and to do consistent, repeatable tests to the best of my ability and with the best equipment that I could afford. If you would like for me to afford better equipment, feel free to buy super things to donate to the channel. I really appreciate when people do that. It's a very inspiring and humbling experience to me. Back to the testing here. The average rounded off to 20% decrease, which means 4 points. And now we're getting into the most nerve-wracking part of my EDC tests, bending moment. So I am applying even pull force to get the knife to bend 15 degrees. The tip of the blade, as you just saw, is rigidly, or as rigidly as hardwood oak permits, mounted in this wooden vise. And I pull it to 15 degrees, set on my carpenter's compass here, and let go. If tip doesn't break off, it gets 1 point. If the blade is not bent, it gets another point. And if there's no damage to the internals from twist test, which exerts exuberant amount of pressure on the internal components such as pivot pins, stop pin, log bar, even screws, then the knife gets a point. So let's take it out and take a look at the blade. Looks straight to me. Sometimes the camera distorts the angle here a little bit, so I'm giving you several positions you can see for yourself. There's no bend, as straight as a ruler. And somebody asked me recently how deep I put the blade into the vise. I go between 1/4 inch and 3/8 of an inch, as you can see clearly marked here on the blade. Here comes the function check. As you can see, it is not flicking anymore. Something did get damaged, and because I'm doing voiceover after I ended filming the video, I already know what it was, and I was able to fix it back to normal. I will show you all that toward the end of the video, because it's Hype Smasher time. All right, before I set it up for the Hype Smasher test, the spine smash, I want to talk a little. In my assessment, this clamping device will emulate a human grip very well, because this steel rod covered in rubber hose emulates this phalanx on your finger. So when you gripped into the knife, this part of the log bar is under your finger and it's bone inside it, right? So it's being pressed that way, in this direction. So when I clamp it in, when I press it down, that rod clad in rubber emulates this part of your hand. So if you have your knife in a workpiece and then you pulled out, it got stuck, and you yanked too hard and came out and struck an object, bam, like this. That's when most of the incidents that people report happen, is that type of application. So if that knife is gripped properly like this, your finger is your log bar lock. So it's a secondary lock here. No, you don't have to grip it super tight. The way impulses work, even a normal working grip, like as firm as handshake, would prevent this from unlocking, because that's how impulses dampen. So the blade will create an impulse, and the way it transfers, your actual hand will dampen it. And the way I clamp all this together is, the knife is not dead clamped. I want it to have a little bit of mobility here, because I am not trying to emulate a bench vise here. I'm trying to emulate a human grip. So I think it's as full of an explanation as I've ever given on this device. So I found these rubber washers in my cabinet, and I folded one up in half, and now it sits between the wooden block and the lock. So the lock is compressed. Let me try to show you the best I can here. And it's not hard rubber, it's medium grade. I don't know what the durometer is. It's porous. So I think it actually emulates this part of your finger quite well. Please notice how the C-clamp at the back of the handle emulates the heel of your hand in a gripped position. And now I closed up the top clamps. Now the knife is fully gripped, and I'm ready to use my modified arbor press, which I lovingly call Hype Smasher. As you probably noticed, the blade sits deep in that trough. I marked that same distance on the ram itself, because I want to keep the drop distance consistent at 6 inches. And this way I ensure repeatability from test to test. Okay, it withstood the first smash. With the frame locks, I won't be able to check function between every strike. So I'm going to go do all 3 in a row. Why 3 times? Because I think it's 3 times as many as a normal sane person would end up doing it by accident in a real world. Because if you do it more than once, you may want to see your favorite psychiatrist. As I remove the knife from the clamp, Please hit the like button now, because you may not like this video after I check it for function. I'm a little nervous because of what happened after the twist test, but I am not seeing any problems, which is great. So, wait a second. Yeah, we're good. Anyway, it flicks the way it was before. Even the lefty flick worked out, so we'll call it a pass. I never seen anyone flick this knife just once. You always want to flick it again and again. I wonder why. So here is my Leeb tester, and first I'm going to verify the calibration. The stopwatch is here to show you that this is going to be one continuous and uninterrupted segment. 787 Leeb points is the certified hardness of this block, and I'm taking an average of 5 strikes, and that tells me a zero shift, meaning how much error I got. So I am off. In lab speak, zero shift means that arrow stacked up to the left or to the right of zero by so many units. In this case, units are Leeb points. One Leeb point is equivalent to 0.07 Rockwell point, so our results will be adjusted to the negative side by 0.14 Rockwell, that is 1400ths of a point. The Leeb testing method is not standard for the knife industry, but it is guided by ASTM A956. I have a link in the description to the PDF of that spec. You are welcome to read paragraph 7.2, which addresses thin light metal testing. And we're going to measure 5 for average. Oh, let's change it to Rockwell. Ooh. So Danny doesn't do his own heat treat. He goes to Peterson. Sorry, not Peterson. Peters heat treat in New Jersey. Our raw average is 65.1. We subtract the zero shift of 0.14, and it gives us 64.96. As you just saw, their measurements were very consistent, which gives me a full confidence in the result. None of it surprises me. I was surprised that the certified range for this blade was given within a span of a single Rockwell point from 63 to 64, because I know that the Rockwell testers are only capable of full accuracy of plus or minus 1.5 point. It's 1 point error and 0.5 point repeatability. So stack them all up, and what you get in reality, every Rockwell tester that I've encountered in my machine shop career way back when was off by about 1.6 points total, 0.8 plus or minus. Anyway, no need to fret over that because the difference of one Rockwell point is actually very minute, and it would not affect the blade's performance. Yeah, so see, on this side we're reading a little lower because something is going on with the flatness, I feel like. I'll finish this, and then I'm going to see if there's some kind of burr on the opposite side. For this side, the average is 62.9 or 62.76 corrected. I don't know. Let's take a look at the tang here. I see something. What do we see here? Here's a little bit of a raised edge, which I haven't noticed before. I think when I was on a hype smasher, something happened that's caused a little bit ding there on the very edge of the tang. My bad, I should have noticed it before I started the test, but better late than never. So I knocked that raised edge with a 800 grit diamond plate. You know, I do make mistakes, and this video is for entertainment purposes only. So don't tell me I didn't tell you that. Let's do another 5. By the way, if the probe strikes the existing dent from the previous strike, it will read too high. Okay. Hit a like if you agree with my test methodology. Hit a dislike if you disagree. I guarantee that even if I had the best Rockwell tester right in front of you on my bench, there would be people who would disagree with my results no matter what, especially if their beloved knife comes in lower than they expected. And speaking of lower, did you notice the last measurement was an outlier to the low side? So if I remove it and correct for zero shift, I am getting 64.12. So we are pretty solidly 1 point over the certified hardness. I'll show you the certificate in a second here. I'm not surprised. I don't think technology exists that would allow a heat treater to target that narrow over the range anyway. And here's the maker's card. And the hardness range is just beneath my finger. All right, so as you can tell, this is not the toughest knife on earth. So the culprit here is this piece. This is the stop that fits in here. And in both tests, Hype Smasher and Twist test, it deformed. I'm going to flip it over on the hidden side that's inside the frame. See, this bump out here is probably to protect the balls from being stuck. The balls are what's controlling the actual deployment of the where's our contact point? I think I'm upside down, right? No. So this it? Yeah. So this is how it all arranges itself when the knife is deployed, like this. So when you push on the log bar, this comes up, and then the knife folds over, and these two little ceramic balls, they engage. These are not holes; these are slots actually. Engage those two slots. So when you deploy the knife, the balls slide across like this, and then when it's in a fully locked open position, the bump here, right there, ends up on the engagement sword. And you can see that there's a little bit of deformation, not major, but there is deformation on both sides. And on this one, because it's probably softer, I think one of the reviewers said it was Elmax steel that this piece is made out of, and it's heat treated, but it's not as hard as obviously a 63 to 65 HRC blade. And so this deforms. It's supposed to be sacrificial, but even so, there's a little bit of deformation here. And what I did, I knocked off that little bump out on the stop piece, and now I feel for some like little bit of a raised edge here. And what I'm using, it's 800 diamond plate, so I'm going to just touch it. It doesn't remove a lot of material, probably less than maybe 1/10 of a micron. So while we are in here, I would like to point out to you that this is indeed a precisely manufactured knife. These pins here, they 127 thousandths slip fit pins. And so now I'm going to reassemble. This goes back in this way. This is also a very tight fit, so you kind of have to come straight at it or it won't properly align. There you go. Now it's flash and the short screw. The rest of the screws are longer. They're the same size but longer. And it's a T8 as well here, so I can torque it pretty good. The question is, did this knife meet the promise spelled out here? Let's check out the scores. All right, in weight size department, for the blade length to weight ratio 1.1, and for being under 4 ounces, it's another point. But it misses out on the blade length because at 3 1/16, it's exactly 1/16 too long to be acceptable in every jurisdiction from legal standpoint. Pocket clip is one of the best features on this knife, or one at least of the more advanced features, because it's extremely well designed. It goes in and out of the pocket with a force of 2.5 to 3.5 pounds. And it doesn't come out of the pocket during the acceleration test. Blade deployment was a dream. I could thumb flick it, I could reverse flick it with my middle finger, and I could lefty flick it upside down. Not to mention the force that was required to open it being between perfect 1.5 and 2.5 pounds. Sadly, locking, unlocking, and lockup strength were not the forte here, because it's not a finger safe knife and it sustained small amount of damage during the spine whack test to the tang of the blade and the lock bar. Where durability was pretty good. The tip did not break off on a pretty severe bending test that I do, nor was there any permanent deformation to the blade after the bending. However, it did sustain an additional small amount of damage to the lock bar insert during my twist test, requiring additional maintenance there. Edge retention was an absolute dream at 20% sharpness reduction, or I should say only 20% sharpness reduction. It scores full 4 points. This knife has a great blade geometry with its full flat grind and 18 thousandths of an inch behind the edge thickness. And the cutting board usable edge exceeded a midpoint on the blade. So 3 points for edge geometry, and that brings us to a total score of 22.1, which I believe is the highest one on my channel to date. So indeed, this knife represents the pride of American knife making and the joy to anyone who is fortunate enough to carry it.